Okay, we're going to start the second video with Lewis dot structures of these molecules. I know they were supposed to be done in your other video, but let's go ahead and work through these real quick. Okay, if you remember that you need to count the total number of valence electrons and find the central atom and go from there. So if you have CO2, there's 4 valence electrons here, there's 6 here, times 2, so it'd be times 2, that's times 2, you get 12 plus 4 is 16. 16 pairs, or 16 electrons. You want to get the pairs, so you do 16 divided by 2, gives you 8 pairs of electrons. Okay, so when you wanted to draw this one, you put your C in the middle because it has less electrons. You bond it to oxygen. You would subtract 2 from 8 because these two are count as 2, and so now we need 6 more pairs. Now remember, you have to make sure that everything has 8. So if I were to put 2 valence electrons here, 2 here, 2 here, 2 on here, 2 here, and then 2 here. That's 6 pairs of electrons. However, carbon only has 4. So what we have to do is we have to go in here and we have to get rid of these right here and these right here, and I'll put the other one back on, and we have to double bond this. So you're going to take and put another double bond here and a double bond here. There's 2, 4, 6, 8 valence electrons around carbon, and then there are and then we take off 2 here, minus 2, so that leaves us 4 more pairs, and so that's our lone pairs. Okay, one of the things that I need to talk about is these are considered lone pairs. These are bonding pairs. Okay, let's take NH3. N goes in the middle. You bond 3 hydrogens. Okay. Nitrogen has 5 valence electrons. Each one of these has 1, so we're going to have a total of plus 3 gives you 8 divided by 2 gives you 4. So we need 4 pairs. If I already bonded 3, I take 3 away, and I need one more pair, and the only place it can go is on nitrogen. Okay, so that's just a little touch up on Lewis dot structure. How do we draw the Lewis dot structure or diagram for polyatomic ions? Well, again, you count the valence electrons needed for the covalent bond. You add or subtract other electrons based on the charge. And if you remember, a positive charge means they lost electrons, and a negative charge means they gained electrons. So if you have ammonium, which is NH4 plus, you have 5 electrons here plus 4. So 5 plus 4 equals 9, but we have to take 1 away from that because of this positive here, and we end up with 8 valence electrons. NH, H. Okay, and then you add your plus sign. Okay, so we'll do sulfate in class. So I want to get into the types of covalent bonds that we have. Nonpolar bonds. Nonpolar bonds means the electrons are shared evenly in the bond. Electronegativity difference is 0. And between identical atoms, diatomic molecules. So diatomic molecules are your magic 7. Magic 7. The ones that we put on our periodic table. Okay, so the other type is a polar bond. Electrons evenly shared. The electronegativity is greater than 0, but is less than 2.0. And here's what we said. We said it was less than 1.7 is really our key here, not 2. Is what we're going to use. So the closer to 2, more polar. Okay, more ionic characteristics. If we go over 1.7, we are going to be ionic. So sometimes the bonds within the molecule are polar, and yet the molecule is nonpolar because it is shaped symmetrical. So okay, and this is, we'll get into this later, so skip that. So just remember this, come to class. Oh, and to get the electronegativity, you're going to find the difference. So you're going to subtract. And we'll do some of that in class, okay? Have a good night, guys.